the distributive property of multiplication over addition. The distributive property says that multiplying a sum by a number is the same as multiplying each addend by the number and then adding the products. So, if we look at this multiplication problem represented by rectangles, because we've learned that every multiplication problem makes a rectangle, you can see that the dimensions of this rectangle are 3 by 5. And 3 times 5 tells us the answer to the multiplication problem, which is 15. The only difference here is that I've spread it out into 2 separate widths other than 5. So we could say that 3 times 5, multiplying a sum, 5 is the sum, is the same as multiplying 3 times 3 and then multiplying 3 times 2. 3 times 3 is 9, and 3 times 2 is 6. And 9 plus 6, adding the products, is 15. How could this help you if you forgot that 8 times 7 was 56? Maybe you forgot 8 times 7 was 56, but you remembered that 8 times 5 is 40. And 8 times 2 is 16. And 40 and 16 make 56. The distributive property is going to help us make math something we can do mentally. The distributive property allows us to use mental math. Partial products, which some of you have used in class, proves this property true. Partial products means find 2 products and put them together. So instead of figuring out 4 times 27, I would figure out 4 times 20, and then I would figure out 4 times 7, and I would add those together. So this is 80, and this is 28, and so 108 is the answer. This is the distributive property, also partial products. 5 times 15. Now, this may not be the way you choose to write it, so I also want to show you that if you use the grid, you are using the distributive property. The grid will help you figure out which numbers to multiply. So we're going to multiply this number by 15. Instead of doing that, we're going to multiply this number by 2 addends that equal 15. 10 and 5. 5 times 10 is 50, and 5 times 5 is 25. Adding these together gives us the answer of 75. Now, if this is the method you prefer, you would have to be able to tell me the 2 problems that this formed. But from here, you could say 5 times 10 plus 5 times 5. So, here it is in real life. Here it is making a little bit more sense, hopefully. Let's look at it with colors first. Red is the number we are distributing. Distributing means to pass out. So we have passed the red to everything inside the parentheses. So we passed the red to the yellow, and we passed the red to the blue. Now, let's think about that in terms of truth. God loves us. God could be represented by the number that is outside the parentheses. The parentheses could be represented by everyone in the world, because it's true that God loves everyone in the world. And then this is who us is made of. So we may say, God loves, multiplication is loves, us. Well, who is us? God loves you plus me. And here we are inside the world receiving God's love. It doesn't change whether you say God loves you and God loves me. God's love is distributed to every single person inside the world. So, what about variables? Again, these these would be evaluating expressions or simplifying expressions, because evaluating an expression is what you do to find the value. And if you don't know the value of a c, you can't evaluate it, but you can simplify it. So, the easiest way to do this is to think about 3 loving c and 3 loving 5. So you may say 3 loves c and 3 loves 5. Now this can't be simplified because we don't know c, but this can be simplified. So our expression becomes 3c plus 15. Let's look at it inside the box method. The two numbers you're adding are c plus 5. The number you're multiplying it by is 3. Again, setting it up like this helps you see that 3 times c is 3c and 3 times 5 is 15. The answer you have here is the same answer we got here. Let's try another one. 4 times x plus 4 times 7. 4x plus 28. Looking at it in the box, the number that's outside the parentheses is the number that's outside the box. 4 times x is 4x, and 4 times 7 is 28. Let's look at it one more time, paying attention to the fact that this time it's a subtraction sign. So we would do 6 loves 5 and 6 loves 2. The only difference is where I put that addition sign, I should put a subtraction sign. So 6 times 5 is 30, and 6 times 2 is 12, and 30 minus 12 is 18. So, push pause and use the distributive property to solve these problems. 9 times 34. Two ways you could have done it on your paper. I'll show you both ways. 9 times 30 plus 9 times 4. 9 times 30 is 270. 9 times 4 is 36. So we could say that 306 is our answer. What if I wanted to show that using a box, because this is more difficult? Definitely an option. 34 is made with a 30 and a 4. 9 is outside the parentheses, so 9 is outside the box. Same answer, different way to set it up. 16 times 5. This time we'll start with the box. 16 is the number I can break in half. I can break into two numbers. 16 times 5 would be the same as 10 and 6 times 5. 5 times 6 is 30, and 5 times 10 is 50. And 50 plus 30 is 80. Now we're getting down here, and again, you can use this method or you can use the box. X plus 2 times 4. 4 times 2 is 8, and 4 times x is 4x. 3 plus n times 5. N plus 3 times 5. 5 times 3 is 15, and 5 times n is 5n. So my answer would be 5n plus 15. And up here it would be 4x plus 8. So the distributive property says that you can multiply it by a number, or you can multiply it by two add-ins of that number, and then add the product.